In today's lecture, we discuss on the fluid kinematics. Let us take the first part, the fluid kinematics part. In the fluid kinematics, we study about the behavior of the fluid when the fluid is in motion. So today's focus is on the types of fluid flow. That's the today's lecture emphasis. So the topic is fluid kinematics. As I mentioned already, fluid kinematics deals with the geometry of motion of fluids without any reference to the forces causing the motion. It involves mainly description of motion of fluids in terms of space-time relationship. Kinematics deals with the velocity, acceleration of the fluid. Now coming to the second point, how to describe description of fluid motion. There are two ways of describing the fluid motion. Number one is Lagrangian method and number two is Eulerian method. In the Lagrangian method, in Lagrangian method, any individual fluid particle is selected and is pursued throughout its course of motion, and observation is made about the behavior of the fluid particle. An observer sitting in a moving boat and studying The flow exam- exemplifies the Lagrangian method. In case of a Eulerian method, we identify a point and then study the behavior of the fluid at that point. An observer sitting on the bank of the river and studying the movement of fluid at that point. Eulerian method is adopted in fluid mechanics due to its practicability and simplicity. Now coming to the types of fluid flow. The fluid flow types can be classified as steady and unsteady flow, uniform and non-uniform flow, laminar and turbulent flow, one-dimensional, two-dimensional, three-dimensional flow, compressible and incompressible flow. Rotational and irrotational. So these are the various types of fluid flow. Number one is steady and unsteady flow, uniform and non-uniform flow, laminar and turbulent flow, one-dimensional, two-dimensional and three-dimensional flow, compressible and incompressible flow, rotational and irrotational flow. So let us take one by one. First one is steady flow. So when you are studying about steady flow, first thing you should remember two words. The words are with respect to time. That is the first word that you should remember. Second one is at a point. These are the two words that should be there in your mind. Now, when I start, what do you mean by steady flow? Steady means what actually? Steady flow means the fluid and flow characteristics such as velocity, pressure, density does not change with the time at a point. With the time at a point. These are the two words. Mathematically, it is given as dou v by dou t is equal to 0. Dou p by dou t is equal to 0. Dou rho by dou t is equal to 0. Velocity does not change with the time. That means velocity is constant with the time. When velocity is constant with time, naturally its derivative should be equal to 0. That's what precisely we have written here. But physically, how to explain it? For example, you take yourself standing on the bank of a river. Yet, wherever you are standing, that is the point. Now, at that point, you are finding out the velocity of flow at 6 o'clock, 7 o'clock, 8 o'clock, 9 o'clock, 10 o'clock, 11 o'clock, 12 o'clock, 1 o'clock, 2 o'clock. Like that, continuously you are taking the velocity measure or taking the velocity readings or the finding out measuring the velocity. At all these times, the velocity should be constant. The velocity should not change with the time at that point. Then we call that flow as a steady flow. You can ask what is the example, sir? Now you take flow through a pipe, flow through a pipe of constant diameter, flow through a pipe of constant diameter at a constant flow rate. This is the best example of it. And most of the cases that we study in this course relate to steady flow only. Unsteady flow cases we will not study at this level in this course. Then coming to the second point, this is unsteady flow. Then just based on the previous one, you can write the definition. Here also again with respect to time at a point. Again the same, the fluid and flow characteristics and flow characteristics such as velocity, pressure, density changes with the time. Mathematically, dou v by dou t is not equal to 0. V by dou t is not equal to 0. Dou rho by dou t is not equal to 0. The example we can write it as the flow rate is increasing or decreasing in a pipe. Further, the gradual or sudden closure of valve in pipe flow leads to unsteady flow. So these are the two examples. So the next thing is uniform flow. Here you need to remember 2 points again in the uniform flow. The first point that you should remember is it is with respect to space. It is with respect to distance. Again, it is at a time, at a given time. So these are the 2 points that you should remember. Now, how to explain it? If the velocity of flow does not change both in magnitude, and direction, from point to point, in the flowing fluid, for any given instant of time, then the flow is said to be, then the flow is said to be uniform flow. In simple, velocity of flow does not change with distance. Mathematically, dou v by dou s is equal to 0, where s represents the distance, and this is at a given time t that we should remember. Then what is non-uniform flow? Exactly opposite of the above. Velocity changes with distance. Velocity changes along the length. Please remember the velocity is a vector quantity, so both magnitude and direction both are important. Even if one changes, it cannot be considered as uniform flow. Mathematically, we can write it as dou v by dou s is not equal to 0. So the best examples for uniform flow and non-uniform flow, we can consider flow, for example, for uniform flow through a straight pipe. I'm very clear in this straight pipe, flow through a straight pipe, sorry, of constant diameter. Then non-uniform flow around a bend in pipe. Most of our study will be on uniform flow. Then let us go into the third point, which we call it as laminar flow and turbulent flow. First, laminar flow. On this side, I will write turbulent. Here in laminar flow, the fluid particles move in layers. Fluid particles move in straight lines. Fluid flow appears as if the layers are moving adjacent to each other. And this is possible only at low velocity and the fluid viscosity is high. These are the two cases, but above three are definitions. First one is fluid particles move in layers. Second one is fluid particles move in straight lines. They won't cross each other. The fluid flow appears as if one layer, the other layer, one layer, adjacent layer, like that in layers, the fluid flow is taking place. All this is possible only at a very, very low velocity and when the fluid viscosity is high. In the same thing, if I put in a figure, for example, suppose if you consider it as a pipe, right? If this is a pipe wherein the flow is taking place through it like this, then if the fluid particles are moving like this, they are moving in parallel paths. They are all moving in straight lines and parallel paths. If the fluid flow is taking place like this, so each fluid particle is moving clearly in straight lines, then this is called as laminar flow. Coming to the other one, in the case of turbulent flow, the fluid particles move in zigzag fashion. Fluid particles movement is such that is crossing each other. Here, this type of flow is generally when velocity is moderate or high and viscosity is less compared to the previous. And here, in this case, if you take it, suppose if this is a pipe, so now flow is taking place here also. Then how the fluid particle here will be moving like this fluid particle crosses, this fluid particle crosses here, this fluid particle cross, this fluid particle moving like this. The fluid particles are crossing each other. Then this is the case of turbulent flow. For explanation's sake, fluid particles moving in straight lines, parallel paths is laminar flow. Fluid particles crossing each other, moving in zigzag fashion is turbulent flow. This is possible at a very low velocity, that is laminar flow. In turbulent flow, the velocity is high. Fluid viscosity is very high in laminar flow, it is lesser compared to that. But how to really find out? How to find out whether the flow is laminar or turbulent? Only let us consider pipe flow, flow through a pipe. Here it is done by the Reynolds number, which is represented by R suffix E and which is defined as the ratio of inertia force by viscous force. And it is given by an expression called rho V d by mu, where rho is equal to mass density, V is velocity, it is mean velocity, d is diameter of pipe, and mu is dynamic viscosity. Now, if this Reynolds number is less than 2000, we call the flow as laminar flow. If this Reynolds number is greater than 4000, we call this flow as turbulent flow. If Reynolds number is in between 2000 to 4000, we call this as transition. Here we stop this lecture and take the next part in the next lecture. Thank you very much and all the best to you. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.